Welcome to the video. Today, we are diving into the complete history of a life-saving device that you probably walk past every single day. We are going to explore the evolution of the manual fire alarm pull station. In this documentary, we will cover how cities handled fires in the 1800s using wooden rattles and church bells, how the invention of the telegraph completely revolutionized the fire service, and how the massive cast-iron street boxes eventually evolved into the highly advanced digital systems we see on the walls of our modern buildings today. Let us get started. It is a device hiding in plain sight. We walk past them every single day in schools, hospitals, and commercial office buildings. Painted a bright, unmistakable red, the manual fire alarm pull station is a fixture of modern safety. It provides a direct, physical link between a human spotting a fire and a massive, complex life safety system. When you pull that handle today, a digital signal races to a fire alarm control panel in a matter of milliseconds. Elevators automatically recall the ground floor, strobe lights begin to flash, loud horns sound the evacuation tone, and digital communicators alert the local fire department dispatcher before your hand even leaves the lever. The entire response is immediate, pinpoint accurate, and completely automated. But long before there were addressable monitor modules, printed digital circuit boards, or dual-action covers, sending a fire alarm was a slow, chaotic, and often completely unreliable process. To truly understand the origin of the modern pull station, we have to travel back in time to the mid-19th century. We have to look at how our cities used to burn and how helpless people were to stop it once a fire took hold. In the 1700s and early 1800s, America's cities were growing at an explosive, unprecedented rate. Places like Boston, Philadelphia, and New York were expanding rapidly, but the infrastructure could not keep up. Buildings were constructed almost entirely of wood, and they were packed tightly together along narrow, winding, unpaved streets. They were heated by open hearths, warmed by coal stoves, and lit by open flames like candles and oil lanterns. There were no commercial fire codes, no automatic sprinkler systems, and absolutely no ceiling-mounted smoke detectors. Fire was a constant, terrifying, and existential threat to entire communities. A single overturned lantern in a bakery or a stray spark from a chimney could wipe out an entire city block in a matter of hours. If you spotted a fire in the middle of the night during this era, you could not just pull a lever on the wall and wait for the trucks to arrive. You became the alarm system. You had to scream. You had to run out of your building into the dark, muddy streets and frantically search for a member of the night watch. These early watchmen, famously known as the Rattle Watch, functioned as a primitive security and fire patrol. They carried heavy, specially designed wooden rattles. By vigorously spinning this rattle in the air, the wooden gears created a loud, harsh, piercing clacking noise. This distinct sound was designed to wake up the sleeping neighborhood and immediately summon the local volunteer bucket brigades to start throwing water on the flames. If the fire was already too large to be handled by a few neighbors with buckets, the watchman had to escalate the alarm. He would take off running to the nearest church or town hall. He would physically break into the tower, grab the thick ropes, and violently ring the massive bronze bells. For decades, the ringing of church bells served as the city's official general alarm. When the bells rang at an unusual hour, the whole city knew a disaster was unfolding. But there was a massive, fatal flaw built into this acoustic alarm system. When the volunteer fire companies heard the bells ringing in the distance, they knew there was a fire, but they had absolutely no idea where it was located. There was no specific address or neighborhood attached to the sound of a bell. Volunteer fire companies would rush out of their firehouses and began hauling heavy, hand-pumped water engines through the streets by foot. They were essentially guessing the location of the emergency based on the direction of the bell ringing, the shouts of the crowds, or the faint glow of smoke and embers in the night sky. It was localized, disorganized chaos. Brigades would often run in the completely wrong direction. Sometimes the wind would muffle the sound of the bells, or the sheer noise of the panicking city would drown them out entirely. Rival fire companies would even fight each other in the streets over who got the glory of putting the fire out, wasting critical, life-saving minutes while buildings burned to the ground. As these cities expanded into sprawling metropolises, the church bell system completely collapsed under its own weight. The distances were simply too great for sound to travel reliably. The volunteer fire system desperately needed a way to transmit specific, accurate location information instantly over miles of city blocks. They needed a way to tell the firehouse exactly which neighborhood was burning without relying on a shouting man or a ringing bell. The answer to this impossible communication problem was going to come from a brand new, revolutionary invention. It was the exact same technology that was just starting to connect the entire nation across vast distances. The future of fire alarms relied entirely on Samuel Morse's telegraph. In the 1840s, the invention of the telegraph proved that electrical pulses could be sent over miles of copper wire almost instantaneously. A physician named Dr. William F. Channing realized that this groundbreaking technology could be used for much more than just sending messages between politicians and businessmen. He realized it could be used to save cities from burning to the ground. Channing possessed a brilliant scientific mind, and he envisioned a massive, interconnected web of telegraph wires connecting every single neighborhood directly to a central fire dispatch headquarters. But Channing was an idea man, and he needed a practical engineer to actually build it. He partnered with Moses Farmer, a brilliant electrical pioneer, and together they spent several years painstakingly developing the world's very first municipal fire alarm telegraph system. In 1852, after years of testing and refinement, Channing and Farmer successfully installed their revolutionary system in the city of Boston, Massachusetts. This moment in history was the true birthplace of the manual pull station. However, these original devices looked absolutely nothing like the small, sleek plastic boxes we have mounted on our office walls today. They were massive, incredibly heavy cast iron boxes mounted directly onto wooden telegraph poles on public street corners. They were ruggedly built to withstand brutal New England weather, vandalism, and the test of time. If a citizen in Boston spotted a fire in the winter of 1852, they would run down the block to the nearest street corner and open the heavy iron door of the fire alarm box. Inside that box, there was no simple lever to pull. Instead, there was a brass crank attached to a complex internal clockwork mechanism. The citizen had to manually grab that crank and turn it a specific number of times. As the brass gears inside the box physically turned, a customized telegraph key would tap out a very specific pre-programmed Morse code signal over the city's newly strung telegraph wires. Every single fire alarm box in the city was assigned its own unique identifying number. For example, if you turned the crank on box number 42, the internal gears would tap out 4 rapid clicks, leave a brief mechanical pause, and then tap out 2 more clicks. This electrical signal traveled at the speed of light directly to the central fire alarm headquarters. There, the electrical signal would power a machine that punched holes into a continuous strip of paper, and a massive bell would automatically ring out the number 42 for the dispatchers to hear. For the very first time in human history, fire dispatchers instantly knew exactly which specific neighborhood was burning without a shadow of a doubt. They could immediately ring the specific firehouse geographically closest to box 42, cutting response times down from devastating hours to mere minutes. This brilliant invention fundamentally changed the world of life safety, but it was about to be perfected by a savvy businessman named John N. Gamewell. Gamewell recognized the sheer genius of the Boston telegraph system and aggressively purchased the rights to take the technology nationwide. He formed the Gamewell Fire Alarm Telegraph Company, a manufacturing powerhouse which would go on to absolutely dominate the fire alarm industry for well over a century. Under Gamewell's leadership, the company made a crucial, game-changing mechanical alteration to how the street boxes operated. Turning a crank in a state of absolute panic was difficult for the average citizen, People often turned the crank way too fast or way too slow, which scrambled the telegraph signal and confused the dispatchers. Gamewell engineers completely removed the complicated crank mechanism and replaced it with a simple, spring-loaded pull-down hook. Now, a citizen simply had to open the outer iron door and pull the hook down exactly one time. The physical act of pulling the hook downward manually wound up a heavy internal tension spring. When the citizen let go of the hook, the spring unwound on its own at a perfectly controlled, mechanically regulated speed. This ensured that the brass gears tapped out the exact telegraph code flawlessly every single time, completely removing human error from the equation. This brilliantly simple, incredibly reliable mechanical motion is exactly why we still call them pull stations today. The pull-down motion officially became the universal, undisputed standard for activating a manual fire alarm, setting the stage for the modern systems we rely on to this day. For over 100 years, the iconic Gamewell street boxes stood on almost every major city block in America. They were painted a distinct, bright red and featured a unique roof-like top, earning them the famous nickname of cottage boxes. They became an absolute symbol of urban safety and security. But as the 20th century progressed, American architecture began to change dramatically. Cities stopped building out and they started building up. As massive vertical skyscrapers, sprawling manufacturing factories, and large, complex public schools were constructed, waiting to run all the way down to a public street corner to report a fire was no longer an acceptable life safety strategy. The fire alarm technology had to be brought indoors to protect the occupants trapped inside these massive new structures. This critical transition marked the birth of the modern commercial pull station. Early indoor pull stations were still entirely mechanical, often made of incredibly heavy cast brass or die-cast metal. Because they were now located in private, unmonitored hallways instead of public streets, building owners faced a massive new problem: malicious false alarms. To deter people from pulling the alarms as a prank, manufacturers introduced the break glass station. These indoor boxes featured a thick pane of glass that physically covered the pull lever. A small, heavy metal hammer was attached to the station by a metal chain. In the event of a real fire, a person had to physically use the hammer to completely shatter the glass before they could access the alarm lever. This extra, highly destructive step successfully intimidated pranksters, but it also created a hazardous, dangerous mess of broken glass during real panic-inducing emergencies. As the decades rolled into the 1970s and 1980s, the heavy cast iron and brass mechanisms were entirely replaced by lightweight red plastics and modern electronics. The complicated clockwork gears were permanently swapped out for simple, highly reliable dry contact electrical switches. These became known as conventional pull stations. In a conventional system, the pull station acts as a simple dumb switch. When you pull the handle down, it closes an electrical circuit, reporting a general zone to the main fire panel. To solve the false alarm problem without using dangerous glass, the fire alarm industry standardized the dual-action pull station. Instead of breaking a window, a person must now perform two completely distinct physical motions to activate the alarm. They must push in a spring-loaded lever or physically lift a clear plastic cover before they can actually pull the main handle down. This brilliantly simple design completely prevents accidental bumps from heavy equipment, hospital carts, or careless pedestrians from triggering a massive building-wide evacuation. Today, life safety technology has fully evolved into the digital age. The most advanced commercial systems now utilize addressable pull stations. Inside these modern red plastic housings are incredibly sophisticated green circuit boards and digital microprocessors. Unlike the dumb switches of the past, these smart devices carry a unique, programmed digital identification number. When an addressable station is pulled today, it does not just trigger a general zone. It communicates over a high-speed digital data link to tell the main control panel the exact floor, the exact hallway, and the exact door where the handle was pulled. This point-specific reporting allows first responders to walk into a massive high-rise building and know exactly where the fire started before they even reach the stairs. Modern pull stations are also strictly governed by stringent building codes. The National Fire Protection Association, known as NFPA 72, and the Americans with Disabilities Act mandate exactly how and where these life-saving devices are installed. They must be mounted securely between 42 and 48 inches from the finished floor, so they are easily reachable by a person in a wheelchair. They must be placed within 5 feet of an exit doorway, and they must remain completely visible and unobstructed at all times. If you can't see it, it cannot save you. From a frantic watchman spinning a wooden rattle in the dead of night, to turning a heavy brass crank on a Boston street corner, to the instant digital reporting of today's addressable systems, the core mission of the manual pull station has never changed. It exists to give everyday people the immediate power to save lives the exact moment danger strikes. It is a testament to nearly 2 centuries of incredible engineering and human observation. Thanks for watching. If you want to dive deeper into the technical side of life safety systems, subscribe to the Fire Alarm Guy channel and visit firealarmguy.net for more resources.